Good afternoon. Thank you. What I'd like to do is not give exactly the same talk that I recorded and was played last week. So I'm going to go over some parts quicker and other parts in more detail, and just recommend. One promised me that the talks would be up on the web soon. So this isn't going to be a repeat of the talk that I gave last week. My background, who cares? The point is I come from the world of both music and technology, and worked on analog electronics for a long time, and then software sound synthesis, traditional computer music. And in this community, it's important that I just got lucky and through different friends got to see both MIT Lisp machines and Xerox Altos in 1976 and 77. And I should say, I probably gave one of the biggest insults to the Xerox group that they ever had at that time, because I walked in and said, "Oh, you guys have Lisp machines," because I was from the East Coast, and of course at MIT they made a copy of the Xerox Alto, and I didn't know that history. So when I saw an Alto, I said, "Oh, you guys have Lisp machines here too," and that was not what they wanted to hear. And then I worked at Park Place for a long time. So historical software sound synthesis goes all the way back to the 1950s. And the point was you had a program, they called them sound compilers, but they weren't really compilers. It was a program that read one file that described a bunch of signal processing graphs, and those were your, in quotes, instruments. And you had another file that was a bunch of function calls to these instruments, and that was called the score. And the program, the sound compiler program, went through many different stages of pre-processing the score and then sorting the score and running the synthesis engine. And then in the old days, the synthesis took much more than real time. So it might take hours to compute a couple seconds of music. And so then the playback was sometimes offline. But what I want to talk about here is this first stage of score pre-processing. So that even going back to the 50s, they said, you've got some process that runs before even the score sorting process, where you can write, and again, in the initial languages, you wrote Fortran functions to manipulate the score or to do some sort of algorithmic composition. So there were 3 publications 50 years ago in 1972. One of them, this presentation of the score language that I'll talk about. One of them, the picture at the lower middle, is what's called frequency modulation synthesis. Interestingly, those were 2 colleagues, both at Stanford, Leland Smith and John Chowning. And then hopefully you all recognize the picture on the right as being very early Smalltalk. So there's been since the 50s, a very active research area called music input languages. And some people differentiate between music input languages and music representation languages. But some of them try to look like programming languages. Some of them look like data modeling. Some of them look like knowledge representation. So it is a very rich field, and there are survey articles, etc. One of the early requirements was just a good format for transcribing common music notation. So if you have a melody written out for a singer, how could I get that into a computer? And then the other main activity was describing compositional algorithms. So do you just have a way of describing a pattern and then repeating it or varying it? In the 50s and 60s, things like serial composition and set theoretical composition were popular. So almost every new compositional algorithm has also been represented in some sort of programming language. Now, the organization, we'll see examples, is you generally have sections or blocks, and you split each, as I mentioned before, the score is actually a bunch of function calls to these signal processing graphs. And they may, in fact, have many, many different parameters. The basic ones just being start time and maybe pitch amplitude, maybe spatial position. But then you could have a whole bunch of parameters describing the timbre. So in the score, you often split each of these parameters into a separate expression, where you say, for this whole block, here's the list of pitches, here's the list of amplitudes. So let's get to some examples of what these expressions look like. If I just want to have a constant, I could say, for example, parameter 5 is 74. That's easy. If I want to give a bunch of rhythmic values, I use the keyword rhythm. So here we see what that means with the slashes. It says 4 means a quarter note. So I have 3 quarter notes, 2 eighth notes, 4 quarter notes, 2 half notes. So you could just play out the rhythm as being da 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 da. The same with pitches. I can just give note names. So D, E, F sharp, G. Right? This is an easy way to transcribe. And then I've got all sorts of other opportunities, like just saying random selection within a range. So this next expression, the P9 expression, what that means is 100% of the time, pick a value between 3 and 8.5. So I could even have non-overlapping ranges. I can also move. So I could say, for example, move over 12 beats from the range of C2 to the C3 to the constant note C5, or select from a list. So this figure at the bottom is an example from Leland Smith's original paper. And here he's talking about spatial position. About here you see over 40 seconds a way of describing the random movement of a sound by having this, what we call a tendency mask, a changing random selection range. So here's a full example of taking a simple melody that you see at the bottom and transcribing it in the score 11 language. So you see, for some reason, the less than sign is a comment. And what the main activity here starts in the middle of this block, where it says instrument 1 from time 0 to time 108. That's in beats. And then you see a bunch of rhythmic values and a bunch of note values and a constant amplitude. Does that make sense to everybody? So that's just a very simple way of transcribing a simple melody. Now, yeah, this I can skip over. This is the differences of the various versions of score. The point was that the earliest versions was focusing on transcribing common practice notation, and even extremely complex. Like he took one example from a Stockhausen piece that's just very, very complex notation. And Music 11, which we're looking at now, was written in 81, and it targeted a language, Score 11, targeted the synthesis language, Music 11, and ran on PDP-11s with Unix. Now, what I wanted to focus on was a little bit more talking about the Smalltalk side of things. So I don't have to tell you guys that Smalltalk is a language and a library and a development environment. And that since the very earliest years at Park, they always had music examples. They wrote synthesis algorithms in Smalltalk machine code. They wrote music notation programs. Some of the earliest graphical examples from the students were notation programs. And as soon as I got started using Smalltalk in the early 80s, I wrote a series of different packages that went by the names Hyperscore and then Mode and now Siren, and that ran on original Smalltalk 80 and then VisualWorks and then Squeak. And now I'm porting it to Quiz. Well, unfortunately, I'm not now because of my other job. I'm working mostly in C++ for the last month or so. But the figure shows you something from the early 90s of what is the kind of the organization. And you see in the middle, there's this kernel that has music magnitudes and event lists. And then these things called voices, which are ways of taking these abstract music structures and performing them on some sort of specific medium, like a MIDI synthesizer or sending them out to a printing program. So there are many voices that map, I call them parameter or property to parameter mappers. And then on the left, you see event generators and event modifiers, which is what we'll be talking about when we get into the support for Score11. So the music magnitudes, I saw a paper a couple of years ago somebody sent me on somebody, I think they were doing physical chemistry and had this whole idea of units of measure. And these are normally reflexive objects, so it's normally something that holds on to an actual magnitude object, but has extra behaviors. First of all, just to how do you create it? So they have constructors, so you can say things like 1/4 beat, or 30 seconds, or mezzo forte amplitude, or F sharp pitch. So I normally use post operators, unary messages. And this supports mixed mode arithmetic. So I could say 1/4 beat plus 30 seconds, or mezzo forte minus 3 decibels. So I'm always amazed that people don't start a lot of projects by saying, what magnitudes do I need here? And let's make some reflective objects for the magnitudes of this domain. The basic event is just a property dictionary object, and it overrides message not understood. So you can send it messages with the names of its properties, which is another thing that I think, a lot of other languages have. And why doesn't dictionary override message not understood to look if the keyword you're sending it corresponds to a key in the dictionary? The event itself, the event list, just uses composite pattern. So that means an event list is an event, is a subclass of class event, but it also holds on to a list of events and forwards a lot of things to its list. And then the event generators and event modifiers just have constructors for various descriptions of events, and they can generally return event lists. So a simple one would just be a chord. If I said a C major chord, give me your events, that I think you can all understand that would probably give me the notes of that chord. Or a roll, we just say, repeat this event really fast. So those are examples of event generator objects. So here's just a browser showing you the hierarchy of this group. So we have something, an abstract event, then a duration event, then a music event, or just adding more and more both state and behavior. And then under event generator, you've got these intermediate abstractions like cloud and cluster and ostinato. And then the Score11 object is going to live under there. So the idea was to just take a Score11 instrument block like we saw before and wrap it to be a constructor expression. And it's pretty easy. We'll look at examples, but the Score11 instance can then parse all of these parameter expressions from the Score11 language. And the Score11 instance can then execute the score block and return a Siren event list, so that you can then use all the rest of the Smalltalk operations on the Siren event list to post-process it. And you can use these voice objects to perform it. So here's, I guess we don't have to go into the examples of this method, but most of the Score11 expressions translate to fairly simple methods. I think the longest one is probably 30 or 40 lines. And they mostly, as you see in this block, at some point, it just goes through an event list and assigns values, adds events or assigns properties to the events in the event list. So let's look at a Score11 example now translated. So this is actually a class method. It's a constructor of the class Score11. This is running in VisualWorks. And here you see that, just like I did in the Score11 example, I don't have a pointer, unfortunately, but the first executable line says S11 is a Score11 instrument 1 from 0 to 9. And then I give it a bunch of rhythms and a bunch of note names. And then you'll notice after P6, 7, and 8, I have this expression where I say value map to something. So I'm just adding new elements and saying there's something called glissando and something called position and something called modulation index. So this is just putting these expressions in a dictionary in the Score11 object, and those will become additional properties of the events. So you see in the second to last block, I just say score gets S11 event list. So I'm just getting the event list. And then the rest of it is pretty much sending messages to the event list, like assigning the instruments and setting up a voice and assigning the voice. And then at some point saying score play, and the score will go to its voice and say, hey, voice, what do you do with me? And in this case, if it's an open sound control voice, it will play it real time and send messages out, UDP messages over the internet. So the nested loops, I don't think we need to look at these internal things, but as I said, even the complex expressions in Score11 become these methods that have nested loops where you're going through the sections of an expression, and then in each section, you're going through a list of events. And you normally end up with something like we hear in the third to last line here, where you say event perform some property with some value. So that's just, those are just setting, you know, I'm using perform, but I'm essentially just saying set some property in the event to some value. And it happens that the names of the properties are also indices in the property list. So the voices, as I said, they're specific to an output medium, and they map these abstract parameters to a specific output format. So open sound control, I don't know who knows it, but it's a widely used format for UDP messages, just so that you can send messages between a controller and a synthesis engine. And here, what I'm doing here is just creating an array of either just constant values or blocks that I can use, that I can just for each event, I send it through this and it gives me an OSC message corresponding to the properties of that event. So let's just switch over and look at the examples. And I'm supposed to be watching the time on this screen.
Yeah, you have like 2 minutes.
Okay. So here what we're running is, here we have, this is a shell, just a Unix shell where I'm starting a synthesis server using Sizzle, which is a signal processing language in C++. And here you see I have, I don't know if you could recognize it, but it's what's called Contact. It's a very popular commercial sampler. So it loads in a bunch of instruments from memory and plays MIDI on them. So I can test it. I can test the open sound control by playing an example, a scale. Sorry, obviously, due to Murphy's Law, the workers just started outside with the heavy tools. And I can test MIDI output by playing a scale on MIDI. So now we have, you know, the yellow windows are all Smalltalk, and the two other things are these backend servers. So so this is sort of what I just said. I should say that Siren comes with a whole notebook of its documentation. But now what I want to do is go back up and look at Score11 examples. And so there are a bunch of tests of just each individual feature. And then the melody that we saw before, well, this is pretty much similar to what we saw. This is this example from the 15th century. So if I do that, so that's an example of transcribing traditional music. And then for something a little more complex, here's something where I have a bunch of these tendency masks. And you see they're kind of different sections where the internote onset, that the rhythmic values are given as tendency masks. The pitch values and the amplitudes are all given as these moving random ranges. And then I get that. And then you see I have another block here with another set of these clouds. And I get the excerpt, and I can apply blocks to them, like justify all the pitches to different scales. So I'm sort of mixing score 11 and Smalltalk. But if I just play this, so I guess I can go back and see what the other, so there's some conclusion slides. So just to finish up with the next steps, there are some things still in score 11, but mainly what I'm working to do is get the port into Quiz, and the core of it's running, the GUI isn't running. So I've been watching Juan's lectures on the vector graphics, because the music notation part of Siren is all based on my own vector graphics package that backended to the VisualWorks framework. So it should be easy. And I'm going to bite the bullet and have things that are called morphs. But what questions or discussion? Well, I guess the last reference is just, I published lots of papers going back to the 80s on these different systems, and journal articles and book chapters. And the code is all, the VisualWorks code is all up on GitHub.
And thank you very much for the talk. This was very interesting. And okay, I wonder if there are questions for Stefan. I have to say I really like it. This is a tiny detail of the talk, right? But the magnitude things you described, it's a really beautiful observation.
Does anybody remember that paper? It was maybe 5 years ago, and I thought it was from somebody in South America about units of measure in Smalltalk.
Yeah, it is the work of Hernan, isn't it?
Yes, Hernan.
Yeah.
Oh, the other thing I want to say, getting back to this morning, was just, I like the idea of the prefix messages, but I'm also, I've looked at Faro, and it's so, we used to say, keep adding syntactic sugar, and pretty soon your soup is too sweet to eat. And so I've always been very conservative. And also when we teach Smalltalk, we always used to say, every expression begins with a noun, right? You always start the expression with an object. There's no if, blah, blah, blah. Every expression is object, message, object, message. So a prefix operator, even if it's something useful like logical operators, I'm very conservative about that. Other questions or comments?
So sorry, why are you porting to Squeak? And more generally, why have you been porting this to several dialects?
Well, originally I worked at Xerox and Park Place. And then when I left Park Place and Squeak got popular, I said, well, I wanted it to be in a free version of Smalltalk. And at that time, Squeak still supported the old model view controller. So it was very easy to port over. when they got full morphic, they dropped model view controller. And so I went back to working in VisualWorks. And the problem is just, there is supposedly a free version, but it's hard to get, and it's a couple of years behind. And so I think Quiz is a kind of my favorite system now. Squeak and Faro just have so much bloat, it's going to make it hard for people to learn. So.
Juan, you were going to ask something?
No, I was just about to comment on the prefix notation. I agree, Stephen, with you that we must be very careful before adding new syntax, but this one is very compelling to me.
I mean, I think as long as we didn't use it in the standard libraries, maybe just so that as much as possible the standard libraries. But we saw that paper about other editions, and of course annotations or embedded SGML kind of things. There are reasons for all of this, for type information, for inline assembly. There are lots of reasons, but I like the fact that we always used to hold up a sheet and say, yes, the entire BNF of Smalltalk fits on one page of paper. And of course, at the time when I was evangelizing, we were comparing it to languages like C++ and Eiffel and like Common Lisp, languages that were very kitchen sink languages that said you have to have every possible representation and way of triggering behavior. And I was like that Smalltalk was very uniform. Well, thank you, friends.
So maybe a final question, if I may. How can we help you port Siren to Quiz? What can we do for you?
Oh, that was actually I think I skipped over that slide. I will gladly send anybody or you can download the source code for the GUI classes. It's just, there's a simple display list, display item hierarchy that should, once you've got a vector graphics package, it should be pretty easy to port that. And then the problem is all the tools are written using VisualWorks standard system views. So the last thing I did was just recreating model view and controller in Quiz as dummy classes. And then I realized, oh, you don't even use the same dependency mechanism. The dependency mechanism uses events rather than just regular message send. So having to kind of recreate standard model view controller classes that I could subclass. But I'll gladly post. It's not that big. The display list framework is pretty straightforward. But it's then when you get to display list view, I have nice views that scroll and scale and zoom. And I got used to making things that had two scroll bars. So you've got a zoom bar and a scroll bar.
Oh, that's nice. Okay.
And then I guess the other thing is the real-time I/O is just making a bunch of stream classes that know the specific formats for MIDI and for open sound control. That's not complicated. And I haven't tried. Has anybody done any real-time scheduling in Quiz? Because what you just heard, for example, that last example got up to like 30 notes a second. So essentially like a drum roll, where if there was the least jitter due to garbage collection or something, you would totally hear it.
I don't think we have done anything with that, but it's worth working on that indeed. Yeah.
But you're using a JIT with a multi-zone garbage collector, so in theory, it should be.
Okay, yeah, we should need to run some experiments and see how well or bad we are doing and what needs to be improved, right?
Yeah. It's that old saying, In theory, theory and practice are the same thing. In practice, they aren't.